2 of Systems Engineering as a career panel with Shoal. For you it's been 2 weeks, for us it's been about 20 minutes. We went and got some coffee to mix it up. So this part is going to focus a little bit more on how systems engineering can lead to better project outcomes. If you haven't seen the previous one, I do recommend watching that. I suppose just in case someone hasn't watched it, do you want to just go through and introduce yourselves again? Yeah.
So I'm Mathew Gardiner. I'm an engineer here at Shoal with the Decision Support Analytics team.
My name is Sheena Howell, and I am the program lead for Space Systems Engineering.
Hi everybody, Kevin Robinson, Chief Engineer and Head of Blue Water Program, which is our innovation program.
Awesome. So I want to make sure that we're not going to get confused between systems engineering and project management, because I suppose from experience those ones get lumped together quite often. I know we touched on it in our previous video, but it would be great to just reiterate sort of what the difference is really quickly. Yeah. So anyone want to have a go at explaining that one?
I think I did it last time, so I'm
Yeah.
going to try.
To you,
I'll try to be as eloquent as I think I was in the last video. I think systems engineering and project management often are lumped together, and they're both looking at the, how do you deliver a product, but project management is focused on your cost, your schedule, and your budget. So it's about how many people do you need, what tools, what resources, when do you need them, risk management from a cost, schedule, budget standpoint. Whereas systems engineering is about focusing on the technology. So it's understanding what your user need is, what are you trying to design and solve, how do you put that together, how do you validate it, validate and verify that it works, and then deliver it to your customer. So it's both holistic from start to end of project views, but very different focuses. One is technical, one is on project management, which is cost schedule.
Awesome. That does clear it up a little bit.
But you were better than last time.
More succinct.
More succinct, yeah.
You practiced. So I suppose my first question is, what is the most complex project that you've worked on, and what measures to do with systems engineering did you use to sort of help manage that? So,
That's complex.
I'll give you a second, but whoever can think of something first. But
I guess in my previous career working at DST Group, I worked on another missile system called the JASM, Joint Air to Service Strike Missile. I think I got that right. And Defence was looking to turn it into, rather than just a land strike, a maritime strike capability. And so, working with Lockheed Martin, DST Group, formed a team, large team, complex project. I had to adapt that capability to deliver a maritime strike capability, and I guess it was complex because there's an existing system, but you try and change it, adapt it. So there's lots of issues associated with that, and across many different technology areas, requiring different expertise from across DST, from across Lockheed Martin. And so I guess that was, it was a team of 50 people, and that, I guess, one of the more complex ones and fun ones I've worked on. What was the second part of the question?
How did you manage it, like using systems engineering principles?
Yeah, so in terms of managing it, it was really around, we talked about model-based approaches in the previous video, and I guess what we did was set that description of the system and understood that across everybody and through a model-based approach, and work with individuals to try and understand, as Sheena said last time, look at the interfaces between the different technologies and define those interfaces, and therefore people internally to that technology can start to manage their own space. So I guess from a holistic perspective, you look across the whole program, get that framework in place, that model, understand how things are starting to interoperate, integrate, and sort of go forward from there. I guess that's one thing.
Yeah.
Maybe I'll hand it down the line. Sheena?
Yeah, I think the example example that jumps out to me also is a previous company experience. I worked with a multinational US company that does very large space and aerospace projects, and was able to be part of a team that's working on putting a satellite into space that's going to, a telescope that will see the, so far back in time you'll see the first matter of the universe. That probably could pin what I got to work on, but without saying it directly. And a project like that takes years to develop. So the system engineering begins at the start, about 10 years before you even have a contract to start doing the work. You start doing the system engineering, doing just like Kevin Devine, understanding what the objectives are, who are the stakeholders, how are you going to put it together, and then starting to come up with a concept of a design that then you get to move down phase by phase. I think the more complex the projects are, the smaller the piece of the pie that you get to see, which is interesting because you have systems engineering of your aspect of the system, but there's still a broader context that you fit into. So even if you're dealing with like a missile system, for instance, there are ground segments or transportation or logistics that all fit in that you may not be directly handling as part of your design, but understanding that interface, understanding the impacts, what things you're relying on, that's all part of the process. So I think systems engineering can be implemented in multiple layers at different phases of a project development, all the way through that verification and validation end of it, which is checking that all of the work that has been put into place is done appropriately and you're still meeting the customer expectations and needs of the project. I think you could spend hours and days talking about all of the different ways that you can implement system engineering. It's easier when you look at a more simple project that you have full grasp of if you're designing a technology within a company and you have all the control of it. But yeah, there's gradations of that across the span.
Yeah. Seems quite, lots of systems within systems and managing that. You got?
I think, so I'll go back to my second internship with Shoal. So this wasn't sort of complex from a technical standpoint, but more, I guess, in other ways. So we were trying to create a descriptive model of an upgraded flight safety or range safety toolkit. And I guess the complexity came from just trying to understand who all the different users were and who all the different user groups that we wanted to target in the future, and then understanding and trying to map out all of their needs, all of their use cases, and then flowing that right down to, trying to flow that right down to system requirements, sort of at the software component level. So that was quite complex, just in that there was a lot of different policy. We had to work with defense policy, civil policy. There was technical limitations, security limitations that were all making this quite a complex job to map out this system. And I guess the tool that we used was really helpful in managing that. So it allowed us to sort of focus on different sections and sort of go down into the detail and step back out and see how it all then connects. So having the right tools for the job is valuable.
Yeah, I mean, I suppose a common theme is just how complex a system can get. And I mean, I imagine there's quite a few sort of challenges in communicating that when you're like handing it over to another person or another team. You were mentioning that like projects can take like 10 years or even longer, and obviously not everyone's going to be working on that for the entire, like someone's not going to be working on it for the entire 10 years. And so there's going to be a handover stage. So do you have any tips for how to actually go about that? From like, like communicating, basically taking what you've learned, taking this giant complex system, and then communicating just how complex it is to someone else.
We talked a little bit in our last session about model-based engineering.
Yeah.
And how it's really digital engineering. It's capturing in a digital environment all of the layers of a project and how everything interacts to each other. I think that is one of the key benefits of using a model-based environment, is that you have a single source of truth for the project that ties your original, strategy discussions from, it could be from the government, right? Somewhere completely outside the scope of your current activities, but then you can easily see how everything connects together. So even if the person who was in control of it got hit by a bus and they weren't there tomorrow, you have that documentation of history. That is one of the benefits, one of the key benefits of having a digital engineering environment, is that information is captured and connected in a way that you can see how it ties together. I think not having that then becomes a much harder project. You have to say, well, then it's about more project management type things. Documenting who are the key stakeholders, when's your reporting, where is the information stored, how decisions were made, and all of those become silos of data somewhere that you have to then go work your way through, but you can do it, right? It's about overlapping and having that communication and handoff. It's still possible either way, it just makes it a little bit harder when it's not in one place.
Yeah.
That's great. We're looking at me again. I mean, I guess I would add in. I guess one of the things we use within the systems engineering world is known as the 5 whys.
Yeah.
So you look at some aspect of the design and you ask why 5 times, and you start with something simple. The question is why, and then okay, well, why did we think that, and so on and so forth, and it's sort of a common framework to tackle these things. And I always think about that when you're trying to hand over to somebody. Because that's what they're going to ask is, within that design process, that system engineering approach, decisions have been made, and therefore for people to learn about why a decision for a design or a test or whatever it is, or an interface has been made, you need to understand why. What is the context? So you would in that handover, you would facilitate that conversation so that the new individual can ask those questions why, and that's where, as Sheena's indicating, model-based approaches are an excellent way of doing that, because you can see a specific interface, then you say, well, why is the interface like this? Well, then you've got the context around that. Okay, well, why are those 2 systems there? Okay, well, then there's a context around that. Why do we need that function? Why do we need that? And all of a sudden you back up to the original user requirements. And so that flow of context and why is really key to handing over, I think. So, yeah.
Yeah, that's really useful information. We've mentioned risk a couple of times. It'd be really great to actually touch on that properly now. So obviously with a system as complex as most systems that you will be dealing with, how do you use systems engineering to sort of evaluate risk across the entire system itself?
Maybe I'll have a stab. I guess, Sheena mentioned it earlier that risks always occur at the interfaces of systems. So when you bring in, as I mentioned, a good engineer can design their component very well, but it's when you try and plug that component into a different engineer's component, the risks start to eventuate from that. And so, from a more holistic perspective on the whole program or the whole design approach, you would start with that. You've got to start with the basics, and you have to understand the risks at that point, and then you can then bring them up a level to say, well, okay, there's risk here. What does that mean for the broader system? What does that mean for its operational capability? And that's the role of the system engineer, is to do that kind of abstraction of thinking, to take the widget X doesn't fit with widget Y, and there's a risk there, we've got to sort it out. And what does that mean operationally if we're talking, say, defence? What does it mean to the warfighter if those 2 things don't plug together? And so I guess that's the role of system engineer, and it, I guess, there's frameworks to do that, like FMICA and things like that, and to bring those sort of kind of risks together. I guess it's just about abstracting the information more holistically. Do you want to add something?
I was going to say that there are, measures that can be taken as well. If you talk about tolerancing, for instance, if you've got a tolerance at this level that then stacks onto a tolerance at this level that stacks to a tolerance at this level, you end up having to, in order to avoid the risk that you're at the worst case scenario and all 3 and the part doesn't fit anymore, you end up having to specify your requirements at tighter and tighter tolerances the lower you down you go into your part fabrication. So there is, tangible implications for doing risk management, even at a like a tolerance level. That's an easy one to picture. But doing that across the system in terms of your budgets or allocated availability. So on a spacecraft, you might have available power that can be used. And so it's understanding what's the worst case scenario if all the systems booted up at the same time and you have a spike. Are you, where's that risk, and then bounding how you operate or how you design the system accordingly. But again, it's about those interfaces and looking at worst case scenarios and what are the ranges that we have, and then mitigating that through design going forward.
That's really insightful, good, useful information. Again, we've mentioned stakeholders a few times and interacting with them to understand their needs and wants. How does systems engineering play into that in terms of managing what they want, engaging them, all of that sort of stuff? Did you want to start?
I think that's obviously very crucial, a crucial part of a systems engineer's role. I think system engineer, I think we're in a good position where you've got that technical understanding as well as sort of a more holistic view of the entire system, so that it is helpful in allowing you to engage with stakeholders and be aware of the technical limitations. So I guess with the project I worked on for an electronics company, the stakeholders always wanted this new feature, that new feature, and that new feature, while maintaining the same size and the same battery life and all of that good stuff. And so being able to understand the lower level design and the constraints from the electronics and software and mechanical teams allowed you to have those conversations and push back where you needed to push back.
Make the stakeholder think about their trade-off decisions in that example. They're trading off new functionality with an increased battery life, for example. And I guess that's one of the roles of the systems engineer is to have those kind of technical meets user needs kind of discussions, and to say, well, if you do want this feature, you're going to have a bigger battery, and they haven't thought about that, may not have thought about that, I should say, but and that's one of the roles I see in engaging stakeholders.
I do see that as a unique feature of systems engineering as well, is that people interface, people management side of things. When you're a software engineer, you get to be on a computer all day long and not talk to anybody else except for through IM if you want to, right? Being a systems engineer, if you're not a people person, you may struggle, because it is about, right off the bat, understanding user needs, and then understanding the different stakeholders who are involved, who sometimes have competing priorities, and then understanding what those are and getting the team together to decide what the system is going to look like going forward. I think with almost every project we start with a kickoff meeting with all the stakeholders, and then we do a series of workshops to start eliciting what we're trying to get out of this and what the end state is going to look at in any form of anywhere we're at on the V in terms of doing work for our customers. So stakeholder engagement, understanding your user needs, that is sort of a central value that systems engineering provides to a design approach.
It's interesting to talk about even like pushing back and having a bit of like a discussion with stakeholders. I know from like my very sheltered university education, like you just accept. I haven't even considered the fact, it makes complete sense, but the idea of actually using your system and using your understanding and being like, well, look, you want this, it's going to lead to this, and being able to have that discussion.
Well, like any engineering, it's always a trade. So if you're willing to forego schedule or cost, like spend lots and lots of money or spend lots and lots of time, yes, we probably can get you there at some point, but most projects don't have infinite budget or time, and so it's about helping your customer understand what's in the art of the possible, and understanding then the risk profile of, we can try to push for this, but this is high risk, it'll be ranked here, and these are the implications of that. So it is about more of a discussion. We say pushback, but it's about helping them understand what's there.
The viability of what they're asking for within the budget constraints and time constraints, that's what you really, and also that integration between different requirements. They may be conflicting, they haven't realised that because they haven't gone out to that next level. So it's a whole learning journey for everybody, and as Sheena indicated, your interpersonal skills can get challenged in that environment if that client really wants that additional functionality but no extra power in Matt's example, then you really have to have a frank discussion with them to say, well, the risk is going to go up, the cost is going to go up, and so to take them on that journey is really what it's all about, I think.
Yeah, well, we might have to wrap it up there. I've definitely learnt a lot. Thank you so much. I hope everyone else has learnt quite a bit. Yeah, thank you so much for taking time out of your really busy schedules. Yeah, I really appreciated it. Our audience has definitely really appreciated it. We've learned a lot. Thank
So,
you. Sorry, yeah.
Can I just interrupt quickly? Thank you to
Yeah.
you and the team for some great questions.
It's been a pleasure.
Been a pleasure having here interviewers and to the
Yeah.
team behind the camera. Thank you very much, and it's
Yes.
great to still be involved with the organisation, and hopefully Shoal can continue to do that into the future. So, well, welcome. Any
Yeah.
conversations like this and questions as well from the audience, it's been greatly appreciated. So, thank you to you and the team.
Yeah. Yeah, thank you again to our audience for taking time out of your days to watch. We really appreciate your engagement. Definitely keep an eye out on future events. We've got a couple more coming out. So yeah, thank you.